for this question, right, we want to determine the vertex of this equation by completing the square. So it's a review of what we did last time. So y is equal to x squared plus 6x, and leave a whole bunch of space because I'm not going to be completing the square. So what value do I need here to complete this, to make this a perfect square trinomial? Right? What was the sort of the equation or the method that we learned last class to get that number easily? Sorry? Yeah. So because the coefficient of our x squared is already 1, right? So we just take the coefficient of the x, which is 6, divide by 2, which is 3 squared. So basically we know that we have to add 9 to this to make that a perfect square trinomial. We just can't arbitrarily add things if we're going to change it. So we have to subtract 9 as well. So now if we sort of rework our equation a little bit, we have x plus 3, 20 squared. So that was our perfect square trinomial. And now we're going to simplify this part. So minus 9 minus 16 gives us minus 25. Right? So now we have it in vertex form. So therefore, the vertex is -3, -25. Okay? Completing square is not a hard concept. So you practice, practice, practice. Yes, sir.
Can you show some with a larger coefficient, like 3 or 5 or something?
Again, watch the video from last class.
Yeah, but I got confused with that. That's the thing I always mess up.
Did you watch the video from last class?
I was here.
Yeah, so watch it again and maybe we'll get it again. Okay? And then if you still don't get it, then we can take up some more. Okay? I do want to move on though. Because I mean completing square was the last class. And that's the nice idea of having those videos there. We can always reference it to get deeper in our understanding. Okay? So the other question is the x-intercepts. So in the previous lessons, going back to the first lesson, which was self-review, how would we actually get the x-intercepts? What does it mean first when we say x-intercepts? Alex?
When the y value, when the x value makes a y value 0.
Yeah. So when we want the y value 0, because this is crossing x-intercepts, is what does y is equal to 0. So what values of x will make y 0? So what was the technique that we used to actually calculate that? Sean?
Make y 0.
Make y 0, but then what do we have to do to the other side? To figure out what those values of x should be so that y is equal to 0. It's your favorite F word in math. It's not 4 letters though, it's 6 letters. Right? Factor? Right? So we want to factor this. So the x-intercepts right? So we're going to factor this. So we're going to do the PSI.
Yeah.
So the product is, Zach? -16. The sum needs to be +6. So what are integers? So when two numbers multiply -16, add up to +6. Well, it's a +6, so you get 8 and -2. Right, so we can factor this as y is equal to x. Let me do it by decomposition. So x squared plus 8x minus 2x minus 16. So I have x squared, so I can pull out x on here, I get x plus 8. I'm going to pull out -2 out of this part. Get x plus 8 over here as well. So finally we get x plus 8 x minus 2. So that's our equation in factor form. So as Sean said, we need to make this equal to 0, right? So we have 0 is equal to x plus 8, x minus 2. So as we saw in the video of graphing this using x-intercepts, exactly what we're doing, figure out the x-intercepts, Mr. Condon was, well, he said each of these is equal to 0. Because if any of these is equal to 0, the product is equal to 0. So x plus 8 is equal to 0, or x minus 2 is equal to 0. So therefore, x is equal to negative 8, x is equal to 2, therefore the x-intercepts are negative 8, comma 0, and 2, comma 0. Okay? I can rephrase this. The zeros of this equation is negative 8 and 2. In other words, same concept, but with the term zeros means we're just looking for the values of x that make it 0, the equation 0. So the zeros of this equation is negative 8 and 2. The zeros are negative 8 and 2. Okay? Any questions on that? Tasha?
Why can't you just like keep going this way?
Going
Without
which way?
doing the vertex. Because you can find the vertex on that.
So yeah, we could have done it this way and eventually found the vertex. So how you choose to do it doesn't really matter. In some ways, completing the square is a little bit faster for me. Some of us, because now you have to figure out the axis symmetry, plug it in. Whereas here, if I got the vertex form right away, it took me a couple of steps. Boom, I recognize what the vertex is. Okay? Any questions on that? So I'm going to show you something a little bit different now on how we can get the x-intercepts from the zeros. I know that. So we have this equation, same equation. Some more space. So let me take this. Copy. Page. Paste. Okay. So when we did complete the square, we got y is equal to, what do we get again? X plus 3 y squared minus 25, right? Same equation. We just shown that last time, right? So what happens if we do exactly what Sean just said before, but we want to figure out the x-intercepts? What does that mean? We want what? Well, we want, when the x-intercepts, what are we saying y to be? 0. That's where it's crossing it. So in this case, let's set y to be 0. Right? That's what we're looking for. So now when we have this, what are we doing? We just want to solve for x. Right? So what values of x here will make this equation 0? So in grade 9, when we did linear equations, solving for x was relatively easy. Right? Now we're solving for x in a quadratic. So how will we begin to do this? Eric?
You begin of trying to find what's in the brackets before 5. It's 5 squared.
Okay. So let's jump ahead a little bit. Let's take that first step. Just treat that square part by itself. Right? So if it's just by itself, let's say let's call it y. How will we isolate for y? How will we solve for y? What's the first thing you did in grade 9 math in solving for linear equations? What do we do to both sides?
Add 25.
We want to add 25 to both sides,
Yes.
right? So we have x plus 3, 20 squared, minus 25, plus 25. Purpose of that was, we wanted to isolate for this. So now we have 25 is equal to x plus 3 quantity squared. Right? So this is exactly what Eric is saying, right? So Eric is correct. I'm just spelling out the steps a little bit so everybody can see it. Right? So we have something squared on one side. How do we get rid of the square? How do we get rid of a square? Or how do we do the opposite of a square? So read it?
Square root it.
Yeah, so we want to take the square root of both sides. My square root symbol is not that great. So here, if we square root x plus 3 quantity squared, we just left with x plus 3, that's the whole idea. What's the square root of 25? 5? So is 5 the only number that you can multiply by itself to get 25? Is 5 the only integer, only number you can multiply by itself, because that's what squaring means, you get 25.
Also, yeah, -5.
You also get -5, right? So when you take the square root of a number, there's always plus or minus that value. So it's really plus or minus -5, and that's how we write it. Okay? So now we want to isolate for x still. So how are we going to isolate for x now? Now it's almost back to like grade 9 solving linear equations, right? John.
Get rid of the 3 of them.
Okay, how do we get rid of 3?
U minus 3 of both sides.
We want to subtract 3 from those sides. So we have plus or minus 5 minus 3 x plus 3 minus 3. Right? So now we're left with x is equal to plus or minus 5 minus 3. Notice that we're going to have two answers here.
Which is the two
So therefore, x
Well,
is equal to
Everyone's going.
x is equal to positive 5 minus 3, or x is equal to minus 5 minus 3. Everybody see that?
So those are your 0.
So I took that plus and minus, two different numbers there, so I separated it to the or. So we got plus 5 minus 3 here, so that's one value of x to make this 0. Or the other one is -5 minus 3. So therefore we have x is equal to 2, or x is equal to minus 8. Is that not the same answer we got by factoring?
Yes, that's what it is.
Yeah.
It's
Okay? How do you figure out the x-intercepts? Which method you want to choose, where you want to factor, where you want to complete the square and then do it this way? Your choice, right? In this particular example, we came up with the same answer. It's not by coincidence, math's about truths. If we follow the truths, it will always lead us to the same destination. Okay? So does everybody kind of follow what we did here in calculating our zeros or x-intercepts without having to factor? Right? We did it by completing the square. Questions? So now here's a question. Find the roots, or basically solve the following equation. Okay, you guys want to try this on your own? We want to solve for this equation. So finding the vertex is not solving the equation. Vertex is a particular point on our parabola. Okay. Here we want to find the roots or solve for this equation. Sorry, Zach, what did you say?
You can just move negative 27 over, or you add 27 to the other side,
Okay,
so then it would just be x squared.
so you're saying that, so basically, no, that's not equals. So x squared minus 12x, so you want to add 27. It's equal to minus 27 plus 27. So that leaves us an x squared minus 12x plus 27 is equal to 0.
And you can just do this regular.
Oh, I miswrote something.
Well,
Thank you. Plus 27. PSI? So the product is 27. Sum is negative 12. We're integers.
Can you also just move this way?
yeah,
It
that's
doesn't
right.
work, yeah.
Oh, okay. It's
It
the
does
one
work
time, I'm
out.
sorry, that PSI doesn't work before.
Whoa!
PSI does work.
It does
Nine.
work.
Oh, it does?
Negative nine,
Okay.
negative three.
There you
Nine,
go.
yeah,
negative nine,
Talking
negative
about,
three.
sir.
What are you talking about, Zach? Talking
Zach,
about.
stop denying yourself.
I'm sorry.
So I'll do this by decomposition. So I get PSI. So x squared minus 9x minus 3x plus 27 is equal to 0. I'm going to factor on x here. So x minus 9. I'm going to factor out a negative 3 over here. So x minus 9 is equal to 0. So finally we have x minus 9 times x minus 3 is equal to 0. So therefore my roots are, well, I'll do it the long way, good thorough explanation. So it's x minus 9 is equal to 0, or x minus 3 is equal to 0. So here we have x equals 9, here we have x equals 3. So therefore the roots are 9 and 3. Right? So solving for equation really having in this case is that y value is 0. It's just kind of hidden, right? But you already have the skills to do this.
Plus you.
Last year.
Plus you.
Was this the only way we could do it though? Let me show you this. You had to ask.
Oh, there's even more.
Make your own way.
Yeah,
So here,
just custom design.
I'm not a fan of our favorite F word
Real students.
in math.
Fun.
Fun, no, favorite sex and other words, right?
Forget it.
Sometimes factoring is a little bit difficult. So let me try this then. X squared minus 12x equal to minus 27.
12x.
Oh, sorry, 12x. So, what value can I put here to make that a perfect square?
Plus 36.
Yeah, plus 36, right? So negative 12 divided by 2 gives us negative 6.
I already did this
Square it, and I got what? Plus 36?
one.
Yes. So I have to add 36 to that side now. A little bit different. I added 36 to my left, so I need to add 36 to my right. The truth.
Could you like?
So now, hold that question for a second. I know I have this, right? The whole reason I wanted the 36 there so that I can complete the square. So get x minus 620 squared is equal to negative 27 plus 36 is positive 9. Now I want to solve for x. So I'll take the square root of both sides. So here now I have x plus, x minus 6 is equal to plus or minus 3. Right? Square root of 9 is plus or minus 3. So I want to add 6 to both sides. So I have 6 plus or minus 3. So therefore x is equal to 6 plus 3 for x is equal to 6 minus 3. X is equal to 9. X here is equal to 3. Therefore, the roots are 9 and 3.
Ask a question.
Got the same answer, with different paths, right? So sorry, Zach had a question first.
I don't know if this is right, but couldn't at the start you just move the negative 27 over and then complete the square like that?
You could have, yes, but it was just, now I had to fiddle around here anyways. I might as well just keep the perfect square on my left side. Because if I had done that, then I'll have to bring stuff all back over, right? So you know what you're gonna have to do to complete the square to begin with over here. Just keep it simple on the left side, because you have to take the square root of this anyways, and you have to keep the perfect square alone anyways on this side. Okay? Sean, you had a question?
So those are I'm just saying
Okay.
so we kind of so much
Just talking to the pot.
So really, what is the difference between the two methods?
Nothing.
There's a big difference between the two methods.
One
What is
is
the
less.
difference?
One has more steps.
One has more
one
steps.
uses the terrible 6-letter F
Word. Alright. So, you know, if we're compound factoring, go ahead and stick with the left.
But the problem with the other side is what if you can't square?
That's too bad.
See one of these?
Pardon? Use one of those? So question. Another one. What are the zeros or roots of the following equation? Full of questions today. So y is equal to x squared plus 6x plus 4. Well, for the factoring fans out there, I will appease you. PSI. So my product is 4, sum is 6. What are my integers? What two numbers multiply to 4 add to 6?
You can square this one.
Oh, sorry. Spoiler alert.
Ruin it.
Well, what two integers multiply to 4 and add to 6? Well, the best I could do is 1 and 4. That gives me 5. 2 only gives me 4, so not quite. Sorry, this one is not factorable over integers.
And you can square
Okay. So this cannot be factored over integers. So how else can we find the zeros then? How else can we try? Well, let's try completely square. So first of all, move please, there we go. So PSI didn't work for us. So let's complete the square. So roots, we're looking for y is equal to 0. Okay. So what value will complete the square for x squared plus 6x? Right. So we have to add 9 to this. 6 divided by 2. 6 divided by 2 gives us 3 squared. We got positive 9. We can subtract 9. Right? So we have 0 is equal to x plus 3, 20 squared minus 5. Now I want to solve for x. So what's the first step that I want to start? Sorry, Zach? Let's add 5 to both sides. We got 5 over here now. So x plus 3, 20 squared. What's our next step to solving for x now? Square roots. Okay. So now we have, so what's the square root of 5? We're just gonna leave it as the square root of 5. Okay, because we want as precise answers as we can get,
Okay.
right? So you don't even need your calculators. Beauty of it. Leave it as the square root of 5 is equal to x plus 3. So now how do we solve for x? Sean, you look excited over there. How do we solve for x now?
So,
You have to move everything over to the other side.
No, we're not
No,
moving
no,
everything
you just
over.
move the 3, sorry.
We're not moving the
You
3
minus
units.
the 3 on both sides.
Thank you. We're subtracting 3 from both sides.
You know what I meant.
I don't think he did.
So the value of x is -3 minus the square root of 5, or -3, or x equals -3 plus the square root of 5. So therefore our roots are -3 minus root 5 and -3 plus root 5. Okay, so not quite sure, Matt. Okay. You can't add them because one's the square root. Okay. Almost treat like that square root of 5 as another variable. Okay. Now do we see the difference between factoring and completing the square? What is the difference? One has squares in it.
You can actually complete the answer.
We can actually find the answer. What happens is, if our equation is not factorable over integers, we can still find the roots. Okay? We can still do the factoring thing, but man, now you're gonna find two numbers that add up to 6. Sorry, multiply the 6, add up to 4, but they're not integers. So in other words, there's infinite amount of possibilities to go through trial and error trying to get that. If we go through this, we can easily get those numbers. Find out what the roots are. Okay, so that is one big advantage completing the square has over factoring, over integers. Our roots may not be integers. We're starting to go into that realm, and we'll do log in grade 11 where our roots are not integers. Okay, any questions on that? Good? One last question, I think. What are the zeros and roots of this equation? Do it together or do it by yourself?
By yourself.
Together.
By yourself and do it together.
How about I walk you through this one?
Yes.
Well, how about you guys? You guys walk through with me then. So what is the first thing that we want to do?
See if you can do PSI.
Okay. I can tell you right now, PSI is not going to work. There's only two numbers that multiply 39 and get add to 12.
See if they're square.
Okay. So let's try the other way. Let's complete the square. Okay. So we have y is equal to x squared plus 12x plus 39. So what number, write the x here. What number do I need here to make this a perfect square trinomial? Oh, you get 36.
Divided by 12 and square root.
Divide by, so 12 divided by 2, which is 6. So it's going to be like our brain thinks faster than our mouth, right? So 12 divided by 2 is 6, we square, we got plus 36. So we just can't arbitrarily add 36 minus 36. Understanding why that homework from last lesson is so important now in completing square? So here was our perfect square trinomial. So we got y is equal to x plus 6 quantity squared plus 3. So side question. What's the vertex of this? What's the
Oh,
vertex?
6 and 3.
I wasn't saying.
Vertex is what?
Negative 6 and 3.
Negative 6.
Or positive 3.
What is the maximum or minimum value? Is it maximum or minimum? Was it opening up or down? It's opening up, so it's a minimum value of what? What's the minimum value?
Oh, minimum value is 3.
Thank you. Okay. So just keep that. We sort of know what the parabola looks like. Okay. So when we want the zeros or roots, what is our next step? What do we want to do? All right.
Y
Yeah, we want y is equal to 0. Right? 0 is equal to x plus 6 quantity squared plus 3. Now I'm going to solve for x.
Minus 3.
Minus 3 is equal to x plus 6 quantity squared. How do I isolate for x now?
Square root, both sides.
Square root. So we have the square root of negative 3, so go to x plus 6.
Is it positive and subtract 6 from both?
Subtract 6 from both sides, negative 6.
The thing is, you can't square root of negative.
So this is plus or minus. Eric jumped the gun on me. Does that make sense? Square root of negative 3.
Oh,
Eric,
it's 3.
why does that not make sense?
It's 9, so it's 9.
Well, we don't know what I is, right? Why does square root of negative 3 not make sense?
Because a negative number times a positive number would equal a negative number. You can't do a negative.
Yeah, you can't multiply the same number by itself and have a negative number, right? If you take a positive number, positive times positive gives a positive. Take a negative number, well, negative number times negative number is positive still, right? That was the whole notion of how we start off with quadratics. It's interesting because that x squared was always positive. So conversely, we cannot take a square root of a negative number. There's no real number for this. Notice I said there is no real number for this. So therefore, there are no real. That's as far as we'll go.
So if you
Although Eric knows what I is.
Oh, I
There are imaginary roots which we touch on in grade 11. We'll get into imaginary roots. But all you need to know for grade 10 is that because we have the square root of a negative number, there are no real roots.
So,
Tyler.
Because it doesn't even pass through the hexagon.
Thank you. Looking over here,
you don't expect us to graph this.
no, I can still expect you to graph it. But your vertex is negative 6 comma 3, which places us somewhere over here, right? So this is our vertex, minus 6 comma 3, and it goes up. It never crosses the x-axis. Y can never be 0. It makes sense. There are no real roots. So there are some equations where we cannot factor and get to real roots.
So once we get to
So you can even stop at this
yeah,
point.
that's what I was gonna ask.
Right? So you can even stop at this point, say, you know what? I need to take the square root of a negative number, no real roots, right? But what I want to draw back here is why I ask these questions to begin with. We know what a parabola looks like. Knew what the vertex was, direction of opening. Now you can see that there's no way to cross the x-axis. The answer makes sense. Okay, any questions? So I know I went through a lot today, but hopefully I scaffolded you for each concept well enough. What's next on the slide?
Oh, good notes.
Oh, a question. Whoa.
Whoa, it's great.
I don't like this. I feel betrayed.
I feel betrayed too. Somebody snuck this question in on me.
There might be another one. Is this 6 or 7?
Of this gray rectangle?
So the length of a rectangle is 2 centimeters longer than the width. The area of the rectangle is 168 centimeters squared. What are the dimensions? Geez, a real life practical example that we can use in math,
Yeah, totally ridiculous.
right?
I know.
So, how might we proceed with this? How might we proceed with it?
It's like,
Make y 160.
I wouldn't make anything. First thing I would do is draw a rectangle. Visualize these problems. So we talk about a rectangle, draw a rectangle. It will help us see the problem. So if you draw your rectangle,
what can you see? Again,
right,
see right here.
label your dimensions down. Now you get to what Sabrina's talking about. We introduce a
X
v
plus 2.
variable. So if I was to do this, I draw my rectangle. Well, I'm going to introduce my variable w. So let w equal the width of rectangle. Right? Well, what do I know about the length then?
2 longer.
Length is 2 longer than the width. W plus 2. So my equation, you guys seen this before last, right?
Yeah.
So my equation is area is length times width. You want to use the times symbol. Use the dot. Length times width. Well, we know that length is really w plus 2 times w. Right? That's how we calculate the area. Take the length times the width. What's our area? What is the area of the rectangle?
168.
Thank you. 168. So now we solve for it. So now instead of solving for a single linear x, now we're solving for a quadratic. Well, how do I start? How do you even start solving this? Sabrina?
Make it 2w plus 2w.
Sorry, 2w plus 2w?
I can't see it.
This is 168 equals w plus 2 times w.
I think that's right.
So what is it?
2w plus 2. Oh.
W.
That was dumb. That
Okay.
was better.
So basically what Sabrina is suggesting is we take this and we expand it. So we get w squared plus w, and here we still have 168. Right? Oh, sorry, 2w. Okay, so does this question now look similar to this question? Right? So instead of solving for x here, we're solving for w.
Right one. Oh my god.
So we could factor, we could try to factor this,
I dropped this class.
right? I could break the negative 68. I could subtract 168 from both sides and try to factor it, right? Or I'm just going to complete the square.
Yeah.
So here, what value do I need to add to this to complete the square? Sorry? Who said 1? Oh, thank you, Rachel. Right, 2 divided by 1, so 2 divided by 2 is 1, 20 squared is 1. Right? So we need to add 1 on this side. 168 plus 1 is obviously 169. And we have W plus 1 quantity squared over here. Right? So we want to square root both sides. Square root of 169? Close?
14.
Close, not quite 13.
Almost 14.
Thank you, right? 2 answers. Want to take a square root?
Oh yeah, you got the plus and minus.
Needs to be plus and minus. Right?
Are you have a negative length?
So we get W is equal to minus 1 plus or minus
Shakes
13. So therefore W is equal to minus 1 plus 13. And W is equal to minus 1 minus 13. So W is equal to 12, or W is equal to minus 14.
negative 14.
Geez, Eric, what is wrong with one of these answers? No, this is not scripted, although it sounds like it. What is wrong with one of these answers?
You can have a negative length.
We can't have a negative length,
Oh my god.
right?
That's not how you.
Sorry,
So that's the result of that answer.
Trust us, wait till we get to the end and then tell us the troll.
See, like curve.
So therefore, the width is 12 centimeters, and the width, I'm sorry, the length is 14 centimeters. Okay.
W equals 12, L equals 14.
Just change it.
So here I'm going to strike out W is equal to negative 14 because we can't have a negative length.
Just 2 W's. Okay, then I got it.
Right. Even if this was not a word problem, it will still make sense because here will be negative 14, plug that back in. Over here, L will be negative 12. Negative 12 times negative 14 just happens to be 168. But this doesn't make real sense in the real world. Well, any questions on that? So taking a real world problem, applying some quadratics to it.
I'm not a big fan of a lot of math.
Okay.
Yeah.
Well, I need a second. Wait. The option show kind of looks fun.
Well, it's
So the key concepts.
not so.
So I'm starting to introduce this. So hopefully by the end of this lesson, you've understood that while 2 factors have a product of 0, one of them has to be 0, equal to 0. Actually, that's more of a review of last lesson, right? We see that some quadratics can be solved by factoring, but others can't be solved by factoring by integers.
7.
But finally, the last thing I want to hammer home is solutions to a quadratic equation. It's also called a roots. Okay, so for homework, 2 options.
The second one is a lot shorter than the first one.
Second one is a lot shorter, but determine the zeros of that equation in general will take you some time.
Oh, Google.
Okay, so you have your choice in your homework. We're not going to have time for this mini quiz.
Quiz.